Hello everyone, and welcome to today's webinar, HashiCorp Vault and Adobe, Tackling Security at Scale in a Hybrid Cloud Environment. Please feel free to type your questions during the webinar. We compile all questions and answers at the end of the webinar and send the results to everyone registered. This webinar is recorded, and the recording will be made available after post-processing, usually within about 2 days. With that, let's go ahead and get started.
Hey, how's everybody doing? So my name is Nick Jackson, and I'm a developer advocate here at HashiCorp. And what we're going to look at today in today's webinar is Vault. So we're going to have a look at a couple of things. We're going to look at a short demo of Vault, but then we're going to listen to Chandler from Adobe, and we're going to hear how Adobe have actually implemented Vault and how they run it at scale, which is actually super interesting. So for anybody who doesn't know what Vault is, I kind of want to maybe explain to you the purpose behind Vault. So Vault as a purpose was trying to solve the problem that we have this big issue with security in the modern world. So everything's going to cloud, everything is distributed, you've got everything all over the place. And we've also got this concept now where we're looking at things like zero trust networks. What we want to do with the zero trust network is we want to be thinking that the security is not the be all and end all of the firewall. It's not the firewall that's going to protect you. You need to be thinking about how you're managing your secrets. You need to be thinking about things like TLS. We want to be using things like one-time passwords and two-factor authentication. And Vault was designed to solve a lot of these problems. And in this demo, we're going to have a look at how Vault can be used to generate encryption dynamically, how we can use Vault to generate one-time passwords, how Vault can be used for X509 TLS certificates, and also how we can use Vault to generate dynamic time-leased passwords for things like AWS and also for databases like MySQL. So I already touched on the fact that perimeter-based security was sufficient when you had that physical barrier in your own data center, but it just doesn't really work in today's world. I mean, we're invariably not even in one data center. If you're a large enterprise, it's going to be fairly common you're running in multiple data centers. Some of that may be a private cloud, you may be bursting into AWS, Azure, and GCP, or all of the above. So how to extend that security across those multiple clouds is a real problem. So we've got to be thinking about how we deal with our secure infrastructure. So where are we storing our secrets? How are we managing credentials and tokens and keys? Are they secure? Are we going to be dealing with things like how do you manage access to those keys and for the use of those keys? So policy-based access control. You want auditing. So when an employee accesses a particular token, you want to be able to get the full audit trail of those details. And you've got to be thinking about if security is breached, then how is your data protected? The more complex your network topology, the more you've got sprawling through the various different clouds, the more complex this problem really does become. And Vault sits in that role of being able to provide that security, provide that quality. So what is Vault? So we say Vault is the ability to secure any application on any infrastructure. And we really mean that, right? I mean, it's got all of the capabilities that you can trust. It's got things like encryption as a service. You don't need to implement a million different crypto algorithms in a million different languages. You can use crypto as a service in Vault to have a central area, a trusted area, and a policy-controlled area for your cryptographic needs. We can also use privilege management, so we can do things like rather than a developer having a root password to a MySQL database or having a root credentials to AWS, we can use Vault to be able to generate policy-based passwords, time-based passwords. So if I need to Terraform deploy something, I don't need the keys to AWS to be able to do that. I can ask Vault to generate me a password that may be valid for 10 minutes or the time it would take for Terraform to complete the operation. So the use cases around that, again, it's that secrets management. How do you kind of store sensitive information? Things like API keys, you don't want them floating around in plain text. And encryption as a service, have that standard, have that policy-based control for the entire of the microservices or the application architecture. And being able to allow your developers to have that access. So if you take an access policy, which is nobody has access to anything, people will find a way. People have got to be able to do their jobs. There's a situation where you need that break glass situation, that the site may be down. You need credentials to be able to access the system. You want to be able to understand who has those credentials and when they've used them. And Vault provides all of this capability. So in the existing landscape, we've got things like KMS, we've got Azure Key Manager, you've got capability to do encryption service and Chef and Puppet, Ansible Vault, but Vault really brings all of these things together, and it makes it very, very easy, as you'll see in our little demo. And of course, it scales, right? I mean, if you want to just use the open source, if you're just a small team, you can do so. But then when you need to grow as an organization, Vault can scale with you. There's professional and there's enterprise capabilities depending on what your needs are. So I don't want to spend too much time on this. What I want to do is I want to show you these features, and then I want to let you listen to Chandler and just how amazing a job that Adobe have done with implementing Vault. So let's do that. So what I've got running here on my desktop is an instance of Vault. I've got an instance of Console, and I've also got a MySQL database. Now, I've just got this set up to show you how quick and easy it is that you can get this set up and play with Vault. But in essence, the only command you need to run to get a simple memory in-memory database version of Vault is this command here, vault server-dev. Now I'm using Console as a key value backend, and Vault supports a number of database backends. And the reason I'm running this with Console is that just because I want to show you that when I write a secret, I can see the data in Console, and I can see the data is encrypted in Console. So let's have a look at that. So if I want to write a secret in Vault, I can just use the command vault write. So if I want to write a key hello, and I want the encrypted value of that to be world, I can use this command, vault write secret hello and value world. And when I run that, you can see the data has been written and it's giving me the confirmation back. So if I look into Console, and if I go to the key value store of Console, and I go through to the logical mounts, I just find the right database. So Vault stores a different database for every backend. And one of these in here will have the data that I'm looking for. But basically, if you have a look, you can see that all of the data in the backend store there is encrypted. None of the data is stored in plain text, and that encryption is one of the things that makes Vault secure. Now, if I want to get that data back out of Vault, again, I can just use vault read secret hello. And again, that's going to bring back the fact that I've got the value world. Now the CLI, you might be thinking, well, that's great to be able to interact with Vault, and it makes a great thing for a demo. But how do you deal with this interaction on your systems? Well, Vault has a very, very fully featured API. Anything that you can do with the CLI, you can do with the API. And you can do that by accessing from building the SDK if you're using Go. You can also write your own SDKs in just about anything, any language you want. This is just a RESTful API. If I look at that API to get the secrets back, it's literally as simple as this. So what I need to do is I need to set the Vault token. And I've just got this saved into an environment variable, but this can be passed into the container or anything else that you're using. And the API structure looks just like that. So you're basically just calling that RESTful endpoint to be able to get the data back out. So and you can see there then when I finally get the API, the key right on there that I've returned a 200 OK, and you can see that there's some JSON's being returned and the data value of world. So again, that's decrypting it, and it's passing back the plain text to me to be able to use. How you would use that in production if you want your secrets, then Console Template is an amazing tool to be able to dynamically generate configuration files. You can also use Console End, which is another awesome tool, and both of those integrate into Vault to be able to get those secrets into your application. But what about AWS? So we've said that, like, one of the problems that we have is that I don't necessarily want to give the keys to the castle to every developer when they need to be able to do a Terraform deploy. I also don't really want to be able to have to store those root keys in my CI environment, because what if the CI environment gets compromised? So what I can do with Vault is I can ask Vault to generate me a temporary IAM, and I can ask it to do that with a lease. And by that, what happens is when the lease expires, Vault will again contact the AWS API, and it will delete that user. So by having the Vault key, by having your CI server authenticate against Vault and then requesting the AWS IAM, it gives you that extra layer of security. You're not exposing those AWS credentials in what may be a public or a SaaS-based API like by Travis or Circle CI or something like that. So to do that, what we do is we have these concepts of backends. Now, Vault has a number of different secret backends. You've got things like AWS, you've got Console, you can mount various databases like MySQL, MS SQL, Mongo, Postgres. You can write secrets to Rabbit, one-time passwords, and also there's a feature called Transit, which doesn't actually write a secret, but it will generate it so you can store it in your own database. And that could be really useful for doing things like encrypting passwords, where you want to store the hash of that password, the cryptographic hash of that password in the database that belongs to the application. So to use it with AWS, what we do is we use the command vault mount AWS. And that will mount that endpoint. Now, again, I'm using the CLI, but if you want to configure Vault, you can use Terraform. Terraform as a provider, which allows you to configure all of these mount points when and if you're deploying a new Vault cluster. So what we need to do with the AWS endpoint is we need to write an AWS, whoops, we need to write the keys for that endpoint. So we need to be able to store the AWS keys. So we can do that by writing those keys into Vault, and again, they're going to be stored. So I'm going to use Vault write, and it's going to be AWS config root. I'm going to write the access key. I'm going to set that to an environment variable which I have on my computer because I don't want to be sharing my AWS keys with everybody. And I'm going to set the secret So that's committed those root credentials for AWS. And if I have a look at my AWS console, I can see all of the users that are existing in this staging account. When AWS loads. Now, what if I want to generate that new user? So what I need to do is I need to define a policy. And I need to define a policy, and that's what capabilities does the user have? So I'm going to use a policy which I've got configured here. And you'll recognize this as a fairly standard AWS sort of role policy. So we're just going to give this user permissions to be able to describe instances, describe EC2 instances. So again, I need to load that into Vault. So I can use this command here. So Vault write, I want to write the roles. The name of the role that I'm going to write, I'm calling it describe, and I'm picking up that policy document that I've just shown you as a JSON file. So I write that, and then that stores that into Vault. Now what I can do is I can use that to generate a user credential. But before I do that, what I want to do is I want to set the lease, and I want to set the lease to a sensible limit, because I'm going to be pushing those over the internet, and I don't want those credentials to be sticking around for a long time. So what I'm going to do is, again, I'm going to set some more configuration. I'm going to set the config on the AWS backend, and I'm going to set the lease. So I'm going to set the lease of a minute, and I'm going to set the maximum lease that somebody can request, again, to a minute. This is 100% configurable, and this is dependent on how your company works. What sort of levels do you find sensible? So I write that. So how do I get those credentials? Well, I get those credentials just by, again, using Vault read. And I can use Vault read crews describe. And what it's returned to me there is it's returned to me an access key and the token. So if I export those so that I can use them with the AWS command line. I can now call AWS EC2 describe instances, if I'd set that up correctly. Let's just refresh the AWS console. You can see that the key's then being created there. Yeah, now it's saying entity does not exist. And if you have a look on the right-hand side, just here, that's because actually it's just been revoked. I was a little bit too slow on generating that and getting that up and running. But I can read it, I can do it again. I can generate another credential. Again, let's see if I can get this set up. Oh. So there we go. So there we can see that was working when I finally realized that Access actually has two C's in it. And you can see some of the VPCs that we've got running on our environment. And when that expires, which it will do in about a minute, so probably about 30 seconds from now, that key will be removed and that will no longer work. So that's a really nice way of being able to control what permissions and what access people have to your AWS credentials. And you can also control the auditing of those. So you can see there, on the right-hand side, the revoked lease has happened on the key. And when I've just tried AWS EC2 describe VPCs, I'm not getting any access anymore because Vault has deleted those credentials for me. So my Terraform process has completed. I've deployed all of my infrastructure. I don't need those credentials hanging around on my CI server anymore. So I can get them all cleaned up thanks to Vault. So databases. Now databases work in a very, very similar way. And we can have a look at how that works. Again, we're going to use this familiar command, Vault mount database. And we mount the database backend. Now, what we need to do is we need to configure that database backend. So we're going to be telling it that we want to mount a MySQL. So what I'm going to do is I use this command here. So I'm going to use the plugin MySQL database. I'm going to set the connection to my MySQL database. And I can specify things like allowed roles and various other information on that plugin. All of the documentation is available in a Terraform project, and it's dependent upon what the backend is you're using. What is that secret store? What capabilities it has? But we can run that anyway. So what we also need to do, though, is we need to add a profile. So I can add a read-only profile to this. Now, what I'm actually doing, if you can have a look at that command up on my screen there, you can see that I'm passing it some parameters. One is creation statement, and then one is revocation statement. I'm also passing it a default TTL and a max TTL. Now the creation statement, that's the command that I want to execute when I request Vault creates me a credential in my MySQL instance. This is a very simple statement that's just literally going to go and create a user in the database. and it's going to give permissions to everything on it. Now, you can be as specific as you like on that. Now, the revocation statement, what I'm doing is I'm going to drop the user, but I'm also going to terminate any processes that exist belonging to that user. So if the user is running a long-running process, I can also get Vault to kick that process. So it'll completely remove the user. So let's run that. And again, Vault read oops, sorry. So I've got some credentials there. So let's log into my local MySQL instance. So I'm going to use username, specify the password. So I've now got access to my MySQL database. And I can do all the sorts of things that I would normally need to do. So again, this is a situation, let's just think it's the middle of the night and there's an outage. Now, as a developer, I need access to the data store because I need to understand where the corruptions happened. Now, giving developers access to production data store, giving anybody access to production data stores is never the first thing that you really want to be able to do. But I could request that operations generate me temporary credentials, and those credentials, again, could have certain permissions with a time span. So those credentials were active for a minute, and I can see on my right-hand window that that lease has just been revoked. So if I do show tables, you can see that not only have my user being deleted, but also I've been booted out of my connection. So that revocation policy, which was a simple SQL statement, has just taken into effect. So next, this is a bit of a whirlwind tour, and I apologize on that, but I really want you to listen to Chandler because this is a great story. But let's have a quick look at X509 certificates. So why do you want to use TLS? So the firewall's fine, right? Is it? Is the firewall really fine? What happens if somebody manages to break the perimeter and get inside your internal cluster? Now, if you're not using SSL traffic between your applications, and somebody's got the possibility of privilege in one of those applications, then potentially an attacker can sniff the entire of your traffic that's flowing around the system. Now, I suppose we ask ourselves, like, well, why don't we just always configure everything with TLS? The predominant reason why we don't is because it's just a bit hard. Generating keys, generating certificates and root certs and intermediary certs and signing things, it's quite an operational challenge. And then we've got to factor into that how we distribute those certificates. And again, you've got another operational challenge. But Vault's got the capability of acting as your certificate root store. So Vault can generate those intermediary, it can generate those application level TLS certificates and keys for you, and it can do it on demand. So again, let's have a look at that. So we want to mount the PKI backend. And what we're going to do is we're just going to generate a root certificate. Now, this is not what you're going to be wanting to do in production. I'm doing this for convenience because I don't have a great deal of time here. But what you want to be doing is you want to be generating that root certificate offline, and you want to be using that and creating an intermediary certificate. Now, you've got to remember, if your root certificate is compromised, you've got no capability of revoking anything without completely replacing everything right the way through the system. So the intermediary certificate, and there's a great guide on Vault Project on how you go ahead and do that. But again, just to show you how easy it is once you get that root cert set up and those certs set up, we can just generate that certificate. So I generate vault-write, and I tell it that I want a common name of demo.js and a TTL of 240 hours on that certificate. And it will give me back all of those, the details there. Now, to be able to, for my applications to request their own certificates, which is derived from that root, what I need to be able to do is again add that policy. So what I'm going to do is I'm going to set that policy. So I'm going to say that I want to write a demo.js policy. The allowed domains that you can generate from that is demo.js. You can create subdomains of this certificate, and the max TTL that can exist for any of those certs is going to be 72 hours. So I run that. And if I want to generate the certificate itself, I can use this command. So vault-write PKI issue demo.js, that's my policy. And then a common name. So what is the subdomain certificate that I want to generate? And in this case, I'm just going to say I want server.demo.js. And I run that. And you can see it spits it out. So it'll spit out the certificate. It'll also spit out the private key that corresponds to it. Now, if we have a very quick look at how you could implement that. So what I'm doing here is I've got a simple Go server, and I want to use listen and serve TLS, which means that I want to create an HTTP server that's going to be using TLS encryption. I want it running on port 8433, and I'm going to be using a certificate and a key. Now, when my application starts, I can fetch that certificate from Vault. Vault will actually give me back the certificate, it'll give me the private key, it'll give me that back as a JSON bundle that I can then write and use in here. However you want to be able to do that, whether you want to do that on application startup, whether you want to inject that at build time, whether you want to run something like a console template or a process which is responsible for generating that, it is incredibly flexible because, again, what we have is that really easy to use RESTful API. Okay, time's pressing on, so let's get on to the last part of the demo. One-time passwords, two-factor authentication, highly recommended, but not the easiest thing to implement. So if you want to roll 2FA throughout your application, you've got to set up a server, you've got to manage all of the details, and it can be a bit of a bind. And then there's the risk that, well, have I done it correctly? Have I made something insecure in there? But you can actually just leverage Vault, and Vault does it super, super easy for you. So again, we're going to mount the one-time password endpoint, backend. And then I'm going to generate my policy for that. Now what it's given me back is that's given me a barcode. And that barcode is actually a QR code. Now it's a basic 64 encoded PNG. So this is what your user is wanting to use to be able to work with their password manager. So if I copy that PNG there, And if I just paste that into an image, so I'm just using a standard image tag, but I'm prefixing it with data image, which will allow me to use the base64 string directly as it is without having to save it out to a file. And I refresh that page in my web browser, and you can see I've got a QR code here. So to use that with something like 1Password, what I can do is I can just add a new login to 1Password. And I'm going to set up a one-time password. I can use this rather nifty feature in 1Password, which allows me to scan a QR code direct. So it's recognized that. And if I save that, I can see that I've now got my one-time password running there. So if you want your user if you want to validate that code as part of your authentication process, again, Vault can handle this for you. So what I can do is I can use either use the command line, which is not particularly great on server, but the corresponding API endpoint is exactly the same. And I can just paste in my one-time password. So 039945 39995. And you can see that's come back as valid and it's true. Now that password has now expired, so if I run that again, when that eventually syncs out, that's going to return as an invalid password. So again, that one sort of simple step to be able to enable two-factor authentication is so easy. You mount the endpoint, the back end of the one-time password into Vault, and then you can just use the RESTful APIs to interact between that and your application server, so that when a user logs in, you don't need to be worrying about whether your one-time password handling code is secure or not. Just delegate that responsibility to Vault, and you can do that across your entire infrastructure. So that was a very, very quick demo into some of the kind of the more common features that people are using inside of Vault. Vault has a hell of a lot more than this. I haven't shown you some of the things like the authentication backends, which allows you to be able to do that initial authentication with Vault with things like GitHub or LDAP or a number of different sources. And I haven't shown you the capabilities of the audit backlog, which allows you to export all of that sort of audited information to things like a file source or syslog. So you've got that full capability of being able to have that audit trail of when people are performing a particular action against Vault and who is doing it and what is going on. And all of these things, I think, make the product such a super easy, super great thing to use. Open source, completely free. If you need the more advanced capabilities, things like a UI or replication, then of course we have an enterprise product, and you can talk to us about those. But right now, let's have a listen to Chandler. Let's have a listen to how Adobe are doing things and what they're doing with Vault and how they're managing it. I think you'll find this really, really interesting. So Chandler, over to you.
Awesome, thanks Nick. Hello everyone, I'm Chandler Alfin, a security engineer here at Adobe. I'm the lead of our Vault architecture deployment. Excited to talk through some of our use cases and how we are using HashiCorp Vault here at Adobe. You can find me online at rcalfin, GitHub, my Twitter handle there. Before I jumped in to Vault and everything, I wanted to talk through a little bit what Adobe is. When I reviewed some of the prior webinars. It was fun to see everyone kind of talk through what their company was and what they do, because it was a little less known, I guess. When I tell people I work for Adobe, everyone's like, oh yeah, I know that, Acrobat or PDF or Photoshop, and those are definitely valid answers, but not everything that we do here at Adobe. Over the last 30 years, we've had several transformations, with some key acquisitions, and now after 30 years, Adobe is 1,600 plus employees, and I'm really transformed into what we call our three base clouds, and is ever changing. So we have the Adobe Creative Cloud, that's Photoshop, that's Illustrator, that's all of you creative geniuses out there that are far more talented than me. Yeah, I'm sure you're fairly familiar with that. We have the Adobe Document Cloud, Adobe Sign, Acrobat, those products. Again, something that's highly used by several companies out there. And then we have the Adobe Experience Cloud. This is maybe one that teams or people are less familiar with. It's started back with the key acquisition of Omniture, and has expanded into things like Adobe Analytics, Adobe Target, Adobe Campaign, that kind of make up our Adobe Experience Cloud. And that's actually the business unit that I find myself in. So like I said, I started Adobe about 1.5 years ago. And I started on a team that we call ourselves the Core Services Team, supporting digital marketing, or the Adobe Experience Cloud, across Adobe. And so what we do and what our responsibility is looking at all of our development teams across digital marketing and seeing what kinds of services or products they're utilizing in order to support their development efforts. And if we see a lot of replicated effort, we take that service and maybe look at it as being a potential core service that our team can host, that our team can develop against, have custom integrations, and then have them consume our service to free up some more of their time. So secret management was one of those, it fell into that category, and that was actually the first project that I was given when I joined Adobe. They asked me to take a look at our secret management solution, some of the things that we were doing as it was, and maybe look at how we could make it better, look at a possible new solution. So with any new project, obviously there's challenges that we are facing, and some of these challenges cause me to look like the icon there down in the bottom. My head hitting my keyboard. I think it's not anything particular to what Adobe faces. It's really just as we expand into this hybrid cloud, distributed, heavy, high-scale environment, any company or organization is going to experience. So I wanted to talk to a little bit of those, because I'm sure they're things that you're experiencing on your end. So first, I already talked a little bit about it, but lacking a company-wide solution, and actually in Adobe terms, this was a business unit solution across digital marketing. It wasn't that we didn't have solutions in place, it's that we had several solutions in place, and teams were doing a pretty good job of securing their secrets, but it was taking up a lot of time and a lot of effort because they were having to do all of the management, and in some cases it was very manual. Things like secret rotation or key rolling. It's very difficult to rotate a secret that's shared by several applications, and trying to align with CMRs and timeframes for several different teams. Secret sprawl, policy management, all of these are things that we had to take into account as we were looking at a centralized solution. No centralized auditing was something that was very difficult for us, as we have very strict guidelines and policies that we have to follow, being Adobe, not being able to look across all of the organization and know exactly what people were doing was difficult, having to go to each individual team. So next was secure introduction of keys. This was a fun one and not a fun one at the same time. This is your classic chicken and egg issue that you run into whenever you're looking at putting a secret management solution or a centralized secret management solution. We had several as we were going across to engineering teams and taking requirements and asking what they've used and what they like and don't like. we had several teams come to us and say, isn't this just I'm using a secret to get my secret, and then I have to secure it with another secret? You know, you have your secrets, you stick it behind an API, then you have an API token to access those secrets, then you need to encrypt that API token with another encryption key, and it just becomes this chicken and egg issue very fast. We knew there wasn't a perfect solution for this, and it was something that we were going to have to develop against, but we wanted to find something that would help us solve this issue and make it easier for our teams to stick their secrets in a secure location and then not have to worry about the secret to get the secret. So I put microservices down as a challenge we were facing. Obviously, moving our development to microservices and leveraging that the platforms that we are, it's definitely a strength. We love that, and we're moving in that direction. But as anyone who's dabbled in microservices and started that, it introduces a whole level of secret management issues and concerns. And so that was something that as we were moving forward into this more centralized, secure way to manage our secrets, we had to take into account. The last one's right along those same lines as, you know, I put it here on a slide with concerns, but you know, a large-scale distributed hybrid cloud environment, that's a strength that we are very happy about, and we're glad that we're heading in that direction. We're glad the business is doing well enough that we have to be on a large scale. That being said, it introduces a whole variety of concerns that we had to address with this secret management solution. So I'm, you know, a year and a half ago, talking to all these teams, we went around and started asking, you know, let's get your base requirements and what does this service need to look like for you so that you'd want to use our service. You know, this isn't the first time that we've done this. We'd had several attempts, or, you know, prior to my time here, several attempts of trying to find a core solution for secret management, but it was kind of elusive and a little bit difficult, where it was hard to find a solution that was flexible enough that all teams could really jump on board. So as we were doing that, it was kind of interesting. We had several companies and products that we were evaluating. We were asked by multiple teams, hey, have you looked at Vault? Have you evaluated HashiCorp Vault? And some teams saying, hey, we have our own open source version of Vault, and it'd be awesome if it was a core service that we could just consume. So that led us to evaluating Vault and looking at what it could help us accomplish and really what it could do for us. And from our, you know, couple months of evaluations, Vault won hands down to helping us accomplish the goals that we had and kind of tackling those concerns that all of us face when we're trying to when we're trying to dabble in a centralized secret management solution. Some of the key features, I'm not going to go through all of these, but probably one of the biggest, honestly, was just an easy-to-use REST API. The other solutions that we had tried prior to Vault, that was kind of the biggest pitfall, is it would fit the use case of a couple teams, but not every team. And if we tried to force them to, you know, refactoring applications and rewriting a whole bunch of code, it just really wasn't worth the headache for them to use it. They just continue using their own way of managing secrets, which was compliant and working, just still had the struggles that we've already talked about. So that was probably top of line for us, and we loved that Vault was so flexible. In fact, it actually introduced another problem for us of teams would come to us and say, holy cow, this API is awesome, but I don't really know how to consume it. What's, you know, give me a best practice or a one way to do it. And so we're happy to have that issue as opposed to the issue of, hey, I can't use the service for this. They were willing to use the service, just wanted more guidelines, and we're tackling those concerns as they come. Second bullet point, highly available. I'll talk about that a little bit later in the slides, but mainly we're very interested in replication on the scale that Adobe was. Extensive ACL and TTL policies. This was something that you know, most secret management solutions will include and has, but what we really liked about Vault was the the fact that it had such a fine-grained ease of use to setting these policies and getting them set up, and that's something that Nick demonstrated very well in his presentation. Last one I'll touch on here was the response wrapping, and that addressed our main concern of secure introduction, the chicken and egg issue, and kind of relieved the stress off of me, the lead architect engineer of this solution, of now I had a way and a feature that I could take to teams and say, hey, this is how you're not just retrieving your secret with another secret, and this is how you can actually introduce your API tokens or your secrets to your applications without exposing those in plain text or having to deal with that. Now, it's something that it's a solution, and it's something that we use heavily, but you still, there's a number of ways that you can introduce or implement response wrapping into the environment. And so that's the other thing that teams really love, is we're not telling them, here's the one configuration tool that you can use, and that's all, because that wouldn't fit for our use case. We have lots of different things that teams can use and utilize in our microservices implementation, and also on our bare metal on-prem. So this is like super high level. I have 2 slides of architecture, and obviously because of the nature of the solution, we don't want to go in way in depth on exactly how we're doing it and what we're doing, but I wanted to just show this diagram coming straight off of one of our wikis. I mean, this is super basic. We have Vault servers. Vault's a very lightweight binary, runs on your servers. We're backing it with the console storage backend. We decided to go with console because of how easy it was to interact with Vault. That's really the only reason we were going to be using console, was because was as a storage backend, and we felt like it really did what it needed to do well. Ran in the background and kind of hummed along silently for us. Stuck that cluster behind a load balancer, and then via DNS are able to kind of co-locate and send requests where they need to be routed and where they're going. As far as secret backends, it's very similar to what Nick went over. We have the generic secret store. We use that very heavily, just a secure place for people to stick secrets. Transit backend, kind of this cryptography as a service, or encryption, decryption. We love that backend, and teams are using that as a way to not change their application too much. Maybe they have encrypted a way to encrypt their secrets. Now we're just able to get those symmetric keys into Vault, into a secure place, instead of some of the other places that they've been in the past. PKI infrastructure, the SSH key, and dynamic database. Nick went over all things that we're leveraging and thoroughly enjoy using here at Adobe. Authentication backends kind of speaks for themselves. We use LDAP, we use AD, multi-factor, and then application role tokens, being able to distribute out app roles to all of our applications and know that they're being distributed in a wrapped form, in a secure form, and are only exist for as long as they need to. Last part of Vault that was kind of a key seller for us is the audit backend. It's just being able to get all of our information from syslog, from file backends into Splunk, and start really building some good monitoring, some good dashboarding, and some real indicators off of what's going on in our environment. And kind of the key win, I guess, of using a centralized service is knowing when your secrets are rotated and what keys we have out there, and so forth. Last slide here, global architecture. This is a little bit, the reason that we went with the enterprise version of Vault is because of their replication feature. We spent some time for a couple months using just the open source, and it worked great for us. It could only scale so far, though. We couldn't have an application that was calling across the world for its secrets and waiting the latency and time that it would take, and the issues that we were having. And so that's why we started looking at Vault Enterprise, and HashiCorp did a really great job building an elegant solution that really catered and helped us to accomplish the goals that we had. We now have a primary cluster, a beefed up, really good primary cluster that is distributing and replicating its secrets out to all of the secondaries. So a secret that's written in our US West region, within milliseconds, is able to be replicated out into our AWS cluster in a region across the world because of the way that that Vault is handling replication. Several other features that come with Enterprise that we enjoy, as far as the secure introduction feature with AWS, the UI, and the HSM functionality. We love all of those, but replication was really the key for us making the decision to go with Enterprise. And that's what we have. So we were able to accomplish a wide range of goals and tackle some issues that were pretty difficult in the past and have been for years. We're excited about where we're at, but obviously it's a growing solution, and we're ever changing and making it better as we tackle the issues that we've seen, or the issues that we had. More complex issues and questions come, but what we've seen is, and what we like, is that we're built now kind of on a base, a centralized service that is extendable, is flexible enough that we can continue improving our service and making things better as the world of microservices and cloud and everything that we have going on keeps changing. So that's the end of my slides, and with that I'll pass it back over to Amanda.
Thank you everyone for joining for today's webinar, and thank you to Nick and Chandler for presenting. Apologies for the sound cutting out a little bit during Chandler's presentation. We'll see what we can do in the recording to get that fixed for y'all. As we said at the beginning, this webinar was recorded, and we will make the recording available after processing and maybe a little extra post-processing for that sound. We will also send an email to everyone who registered for the webinar, the complete list of questions and answers after we summarize all that data. Thank you so much for everyone for joining, and have a great day.